Good afternoon, everybody. I'm Dilan Anand from EFI Group, and welcome to today's webinar. We are happy to have all of you here. Our session today is on automotive MOSFETs for vehicle electrification, and it's brought to you by Vishay. The speaker for today is Brian, who is the Senior Manager Market Development for Automotive MOSFETs at Vishay. We hope you all enjoy the session, so let's begin the webinar.
Hello there, my name is Brian Terng, and I'm part of the Vishay Automotive MOSFET team. Welcome to join this discussion on automotive-grade MOSFET products for vehicle electrification. This presentation introduces Vishay's latest automotive-grade MOSFET products that promote better energy efficiency, power density, and reliability. The content is for designers who are developing electronic systems to support vehicle electrification. Electrification of vehicles is driving the evolution of automotive industry, and manufacturers are committed to producing more hybrid or full electric cars to reduce carbon footprint. The automobiles with internal combustion engines will gradually be supplemented with electrical propulsion. Therefore, more efficient electronic systems are in higher demand, and the applications for MOSFET are expanding from replacing the mechanical designs in combustion engines to the power management in hybrid and full electric vehicles. To support a wide range of automotive electronic systems, Vishay has formed a broadline approach to enable energy-efficient designs. The latest 20-volt to 100-volt trench FET Gen 4 feature low on resistance and excellent figure of merit to bring high performance to advanced driver assist systems, power management systems, wireless charging, inverters, and motor drives. Our best-in-class P-channel portfolio, ranging from 30 volt to 100 volt, provides excellent solutions for high-side switch and sensors. The leadership RDS(on) minimizes power loss from conduction. If reducing component count is your priority, we offer application-specific integrated solutions. The Powerpack S08L dual asymmetrical product family features a pair of MOSFET devices that are optimized for point-of-load applications in DC-to-DC power supplies. We have recently introduced the 650-volt E-Series superjunction family qualified to AEC-Q101. This range of high-voltage MOSFETs provides solutions for AC-to-DC converters and onboard charging systems. These parts are the only 175 degrees Celsius rated superjunction devices in the market. The extended temperature range offers more headroom and allows higher power dissipation. High-performance silicon technologies are at the heart of energy-efficient products. Our latest invention is Trench FET Gen 4, qualified to AEC-Q101. This platform covers from negative 100 volt P channel and 100 volt N channel today, featuring low RDS(on) to minimize power loss from conduction and excellent RDS-QG figure of merit to improve efficiency of switching applications. The popularization of hybrid and EV has increased the demand for AC to DC converters and onboard chargers. To help these applications, we have introduced an AEC-Q101 qualified 650 volt E-Series superjunction platform to supply efficient building blocks for these systems. All the parts in this new portfolio feature fast body diode to improve reverse recovery characteristics. To better complement the latest silicon, we developed Powerpack packages with clip interconnections, as the clip provides a larger current path and reduces resistance. These bound wireless devices can deliver much higher current and enable higher power density at the system level. Not only the performance is improved, the packages are designed with going leads, which provides maximum thermal and mechanical stress relief and improves board level reliability. Besides high power devices, we also focus on expanding our offerings for integrated solutions. The latest dual configure packages help reduce component and part number count to simplify design. The asymmetrical dual contains two MOSFETs that are optimized for synchronous buck converters, so two different part numbers can merge into one device. Our latest technologies are well connected to the rapid evolution of automotive power systems. The 12-volt systems, which represent the essence of vehicle electrification, are migrating from belt-driven designs to electrical, and the MOSFET content has at least doubled. The new 12-volt systems also need to be smaller and lighter to achieve weight reduction. The start-stop systems have been widely adopted to improve fuel economy. Mechanical relays are being replaced by MOSFETs to save space, to improve reliability, and to lower power consumption. In these designs, MOSFET is usually in the circuit for load switching or brushless DC inverters, and will need to conduct high current efficiently. Our latest 20-volt to 60-volt trench FET N-channel and P-channel feature low or industry RDS(on) and a bound wireless package design optimized for high current. These products minimize conduction loss when delivering high power output to your systems. Depending on the power requirements, we recommend 3 package options: Powerpack A/L for the highest power demand, Powerpack S08L for relays, oil and water pump, and Powerpack 1212-8 SLW for cooling fans and smaller motor drives. The photo on the bottom right corner illustrates a reference design for a power steering system using SQJQ140E in Powerpack A/L. This 40-volt 530 microohm N-channel device has a footprint area of 64.8 mm² and provides much lower on resistance in a 60% smaller form factor than D² pack. The compact size and the very low RDS(on) can help increase power density. As 40-volt products represent the mainstream solutions for a variety of 12-volt systems, we are constantly pushing the technology capability. Let's look at how the 40-volt evolves and compare the progression of devices in Powerpack S08L package, which has a footprint of roughly 31 mm². The latest and the greatest Gen 4 device in S08L is SQJ136EOP. And this device has a typical RDS(on) of 0.9 milliohm. As we have this dialogue, the 5th generation trench FET is being developed in our facilities. The Gen 5 in the same package will achieve a typical RDS(on) of 0.63 milliohm, and this is 30% RDS reduction comparing to the Gen 4. SQJ136EOP also has a QG of 107 nanocoulomb, and QG for similar sized Gen 5 device will be 82 nanocoulomb. This is roughly 23% improvement and will increase efficiency for switching applications, as losses from gate driving and switching will be less, particularly for fast switching synchronous buck or buck boost topologies. Overall, the RDS QG figure of merit will be 45% lower for the next generation. The electrification has fundamentally changed the architecture of automobiles. Cars have become more sophisticated, and the expanded features require high power loads. Running on 12-volt systems would generate much higher current and require larger and heavier wire harness. Moving to the 48-volt board net helps reduce the current requirement without increasing the weight of the vehicles. High power loads, such as power steering, dual clutch transmission, smart electric oil pump, electronic water pump, e-booster, supercharger, and DC-to-DC converters will all utilize the 48-volt systems, as well as the 48-volt battery management, the low switching motor drive control, and DC-DC conversion topologies. In these applications, we will need high-performance products in packages that can transfer heat effectively. To satisfy these requirements, we recommend 80-volt and products with higher VDS ratings in thermally enhanced packages. The 80-volt to 100-volt MOSFETs in Powerpack S08L and A/L provide leadership RDS(on). The bound wireless construction allows more current output and enables higher power density. The Powerpack A/LR, which has the drain pad on the top side of the package, is optimized for designs that rely on heat sinks or the metal enclosures to remove unwanted heat. These packages also feature going leads, which is engineered to maximum mechanical stress relief. Apart from the Powerpack product family, Vishay is also expert in supplying known good die, KGD, to support requirement for bare die products. The KGD devices go through wafer-level PAT testings, multiple defect inspections, and defect control to ensure high quality. These KGD products are shipped and delivered in tape and reel. The rapid growth of 48-volt systems is driving a demand surge for 80-volt and 100-volt MOSFETs. These devices are building blocks for topologies used in low switches, motor drive controls, and switch mode power supplies. The dominant elements causing power loss are quite different among these applications. MOSFET generates higher loss from conduction in slower switching circuit, such as low switch, battery switch, and incur more loss from turning on and off in faster switching systems, like motor drives and voltage regulations. In order to operate efficiently across different switching requirements, both 80-volt and 100-volt MOSFETs need a fine-tuned balance among on-resistance, gate charges, and capacitances to reduce loss from conduction, switching, and reverse recovery. The current best 80-volt products of Gen 4 in Powerpack S08L is SQJ180EP, and the RDS on is less than 3 milliohm. The next generation platform, TrenchFET Gen 5, is expected to reduce RDS on by 20%. As an optimization for fast switching applications, we also emphasize the aggressive improvement of figure of merit. The Gen 5 has a target to lower the FOM by 33%, from 180 milliohm nanocoulomb to 120 milliohm nanocoulomb, and the decreased QG will cut the power loss from switching. The result is increasing system efficiency and reducing temperature rise during operations. Selected designs of 48-volt systems need 100-volt MOSFET due to the additional voltage headroom. In 2020, we released the 100-volt Gen 4 platform with SQJ12EP as the development vehicle. The device has aluminum wire bonding, and the resistance of the package ballooned the RDS(on) of the final product to 7 milliohm. As bound wireless package was released, we implemented that design with Gen 4 silicon to create SQJ110EP. The result is improving RDS(on) by 38% as the bound wireless interconnection drastically reduced the resistance from the package. This overall design also allows higher drain current and helps increase output of individual device. The Gen 5 platform, which is in development now, will also have aggressive figure of merit improvement to achieve optimized balance of RDS(on) and AC characteristics. Combining with the bound wireless package, the lead device SQJ510EP will achieve a typical RDS(on) of 3.5 milliohm. The QG will be 33% smaller than the Gen 4 to improve switching performance. The target for the technology release is in the second half of 2022. As our roadmap demonstrated previously, Powerpack packages with bound wireless construction are more optimized for the latest technologies. Due to the enhanced power dissipation and minimized package resistance, these packages provide excellent replacement for legacy D2Pack, D-Pack, and S08. Currently, the bound wireless option is available for Powerpack 8x8L, Powerpack 8x8LR, Powerpack S08L, and Powerpack 1212-8 SLW. These packaging options have exposed drain pad either at the bottom side of the package or at the top side to allow better thermal transfer. Designing with power packs also require less PCB real estate compared to the legacy packages. Using Powerpack 8x8L instead of D2Pack can help reduce PCB real estate for MOSFET up to 60%, and the power density of the final system can be increased. Powerpack family also provides alternatives that are 40% to 60% lighter, and migrating to these packages can save weight at system level. For example, the Powerpack S08L weighs 0.09 grams and provides a 70% lighter device than D-Pack. A braking system or water pumps using Powerpack S08L instead of D-Pack will be much lighter and more efficient. The Powerpack family offers devices from -200 volt P channel to 200 volt N channel, and the package footprint areas range from 4 to 81 mm square. All package types are qualified to AEC-Q 101 and have temperature rating of 175 degrees Celsius. The configurations include single, dual, and dual asymmetrical. The dual asymmetrical option encapsulates an optimized pair of MOSFETs. One is a smaller device with low QG, suitable as a control switch, and the other is a larger device with low RDS(on), ideal for synchronous switch. They offer application-specific solutions for synchronous buck converters, with duty cycle below 50%, as the high side and low side MOSFETs for buck converters are now in one package. These integrated devices reduce component count for the DC-DC conversion circuit. One distinctive feature for the Powerpack S08L, 8x8L, and 8x8LR is the going-shaped leads, which are designed to maximum stress relief and to achieve superior board-level reliability. During the development stage, the packages went through rigorous aging and stress tests, including 2,600 cycles of power temperature cycling and 2,000 cycles of rapid thermal cycling. We also perform bending and vibration tests with these packages mounted on test boards, so the final products improve system reliability during the flexing, vibration, and drop events. Looking inside the latest Powerpack S08L, the source and gate of the device use two metal clips as interconnections to the terminals without any bonding wire. The wire-free construction reduces the package resistance to as low as 100 microohm. The wafers are grinded to 50 micron thick to achieve low RDS(on) and superior thermal performance. The proprietary mold compound for the encapsulation features customized properties to minimize CTE mismatch and reduces stress from thermal cycling. The going leads are engineered for maximum mechanical stress relief. Therefore, this package is built to achieve high board level reliability and can reduce the return rate. An example to showcase the competence of bond wireless Powerpack S08L is SQJ126EP. It is a 30-volt N-channel MOSFET with a typical RDS(on) of 0.7 milliohm, and this figure is the lowest among going leaded packages with 6x5 mm square footprint. This device achieves 70% lower RDS(on) than the industry-best 30-volt D-pack device in a 45% smaller package. The RDS QG figure of merit of SQJ126EP is 71 milliohm nanocoulomb, which is best in class and 9% lower than the next best product. For applications such as motor drive control, low switching, relays, and DC-DC conversions, the low RDS(on) and FOM can simultaneously reduce conduction loss and switching loss to be more energy efficient. We have released a large collection of 30-volt and 40-volt devices in Powerpack S08L utilizing the Gen 4 technology. They can be high-performance building blocks for relays, motor drives, battery management, and fast-switching DC-DC topologies. Among our solutions in Powerpack S08L for 48-volt systems, SQJ180EP is our flagship 80-volt product. The typical RDS(on) is 2.5 milliohm and best in class in going leaded 6x5 mm square packages. It has the highest drain current rating of 248 amps, which is 10% more than the best product with the same package footprint. With leadership RDS(on), excellent figure of merit, and construction to enhance board level reliability, SQJ180EP provides high performance and reliability for your next powertrain applications, motor drives, DC-DC converters, and 48-volt battery management systems. To verify the performance potential, we benchmarked SQJ180EP against the competitive 80-volt product with similar RDS(on) in a flat-leaded Powerpack type package. The test platform is a quarter-brick power module using full-bridge topology and converts an input of 48 volt to a 12 volt output. The two 80-volt devices competed in the four primary size sockets in which losses come from conduction, charging and discharging of QG, and output capacitance. This converter has a fixed switching frequency of 175 kHz, and tuning the circuit in favor of either part is impossible. SQJ180EP resulted in a roughly 0.7% higher peak efficiency and supplying 16% more output. The product from competitor was unable to match the maximum output of SQJ180EP as the operating temperature exceeded the limit of triggering thermal shutdown. Apart from SQJ180EP, our portfolio for 48-volt applications include more 60-volt to 100-volt Gen 4 devices to support applications such as reverse protection, motor drives, battery management, and power conversions. Additional parts will be released to help more designs to achieve better performance. Apart from offering leadership and rugged N-channel products, we also supply class-leading P-channel MOSFETs with industry-lead RDS on. The negative 80-volt SQJ81EP has a typical RDS on of 14.3 milliohm, and this figure is 28% lower than the best negative 80-volt device in DPAC. The industry-best RDS on minimizes the power loss during conduction. Driving a P-channel MOSFET does not require using a charge pump, so the circuit for operating SQJ81EP is simpler than using an 80-volt N-channel. It is ideal for applications such as battery management, high-side load switch, and reverse polarity protection. If you need more headroom for voltage overshoot, or your design simply needs a 100-volt device, the negative 100-volt P-channel SQJ211ELP provides industry-low RDS on in the compact and thermally enhanced Powerpack S08L. The typical RDS on is 24.2 milliohm, which is 28% lower than the best product in DPAC. The footprint is 53% smaller than DPAC, while the weight is 71% lighter. Combining the industry-low RDS on, the smaller size, and the weight saving, SQJ211ELP can help you create a lighter and a smaller system. The Powerpack 8x8L package targets high power loads such as battery management, power steering, dual clutch transmission, superchargers, oil and water pumps. We have recently qualified the wire-free construction to increase the performance of the package. The going leads are designed for maximum mechanical and thermal stress relief. Comparing to D-square pack, Powerpack 8x8L is 57% thinner and has a 60% smaller package footprint. This results in 83% space reduction without compromising the capability of delivering high current. The 8x8L package weighs about 0.3 grams and is 80% lighter than a typical D-square pack, which weighs about 1.5 grams. We have also released a reverse version, topside cooled Powerpack 8x8LR package. The drain pad is on the top of the encapsulation and provides a direct thermal path from the top of the package to heatsink. The 8x8LR also feature wire-free construction to minimize package resistance. Comparing to the most optimized aluminum wire bonding arrangement, the bond wireless approach can reduce the resistance contributed by package from 52% to 29% or less. It is optimized for technologies of very low RDS area without adding excessive resistance to the final product. Combining with the latest silicon, low voltage devices can easily achieve RDS on in micro-ohm range. This portfolio for 8x8L supplies high-performance MOSFET products from negative 40-volt P-channel to 100-volt N-channel. The graphic on the right illustrates the RDS on range by breakdown voltages. The latest 30-volt device in 8x8L has a maximum on resistance of 500 microohm, and the best-in-class 40-volt device features RDS on less than 530 microohms. We have introduced 9 products in the Powerpack 8x8L, and there are more products in development. So please stay tuned for more product releases. For design that will be attached to a heatsink or using a housing for thermal management, Powerpack 8x8LR portfolio provides a topside cooled option. This package features going leads for stress relief, and its wire-free construction enables low RDS on and allows a drain current as high as 575 amps. For the 40-volt device, the RDS on is as low as 540 microohms. The exposed drain pad with low thermal resistance is located on the top side, so the heat can escape upward to the heatsink and is directed away from the PCB. As the dominant thermal path is the heatsink, the PCB handles less thermal transfer and can use smaller component. For most MOSFET packages with drain at the bottom side, the heat will be pushed into the PCB through the drain pad and then dissipated to the heatsink. This path includes several materials with thermal resistances in series. The PCB area of the MOSFET will also need vias to allow thermal transfer. Because Powerpack 8x8LR is topside cooled, the thermal management can be optimized by mounting a heatsink on top of the package with thermal paste or gap filler as interface. This setup allows heat to be dissipated directly to heatsink and relieves the thermal transfer from PCB. The PCB area for the MOSFET no longer needs vias. The remaining components can be scaled down, and then the overall design can be simplified to lower PCB cost. As the heatsink takes away heat more efficiently, the system runs cooler and enables operation at a higher power density. Due to the unique design of the Powerpack 8x8LR, we recommend using a stencil with thickness of 200 micron to allow sufficient paste thickness. This prevents the gate pin and source pins from lifting after reflow. The Powerpack 8x8LR portfolio consists of 4 released products from 40 volt to 100 volt. We're working on introducing more 40 volt and 80 volt options to the market by the end of 2021. Apart from products supporting high power loads, Vishay has engineered compact solutions that provide low RDS(on) capability for carrying high current. The latest Powerpack 1212-8 SLW is a package with a footprint of 3.3 by 3.3 mm square. The source interconnection utilizes an advanced clip design to minimize package resistance, and we also increase the die-to-package ratio aggressively to maximize active area. The best 40 volt device in this package can achieve 2.4 million with the Gen 4 logic level process, and this level of on-resistance was only achievable in a 65% larger package before. The package also features wettable flank terminals to promote solder wetting for the formation of solder fillet. The result is a better visual indicator of solderability, so that optical inspection can be made for verifying a good electrical connection. SQS140ENW is the first release for Powerpack 1212-8 SLW package, and it features a maximum RDS(on) of 2.53 million. Its RDS-QG figure of merit of 80 million nanocoulomb is best in class and 7% better than the next product. Due to the combination of bound wireless design, low RDS(on) and very low thermal resistance, SQS140ENW offers the class-leading maximum drain current rating of 214 amps. This figure is 50% higher than the next best product in a footprint-compatible package. The target applications include motor drive control, reverse polarity protection in wireless charging, and DC-to-DC converters. We're working on releasing more parts in the Powerpack 1212-8 SLW package. The new products will range from -150 volt P channel to 100 volt N channel, and they will be released in the next 6 months. Please stay tuned for our future product update. Powerpack SC70W-6L package is currently the smallest among Powerpack product family. This package has a 2mm by 2mm footprint and also features wettable flank terminals to help formation of solder fillet and visual inspection. This portfolio includes -40 volt P channel to 100 volt N channel and provides compact solutions to LED lighting, load switching, and signal switching in connectivity and infotainment systems. As connectivity and in-vehicle infotainment become more sophisticated to enhance driving experience, the hardware supporting the new feature will need voltage regulation and power management. Vishay has released a new solution for the MOSFET power stage required in the DC power supplies. The product family is called Powerpack S08L Dual Asymmetrical, and the devices integrate a smaller MOSFET with low QG for the fast switching control switch, and a larger MOSFET with low RDS(on) for the synchronous switch, which conducts current. The package is qualified to AEC-Q101 for automotive applications. The construction of the package allows the device to operate at high temperatures, as the maximum junction temperature is 175 degrees C. The leads are gull-wing shaped and engineered for maximum mechanical stress relief. Both attributes enable high board level reliability for automotive applications. Utilizing the Powerpack S08L dual asymmetrical MOSFETs help reduce component count in DC-to-DC converters, since you need just one package instead of two for your two MOSFETs. Compared to using two discrete devices, you can save up to 50% of your MOSFET PCB real estate. Besides saving space, you save on engineering effort and increase your power density. The Powerpack S08L dual asymmetrical portfolio supports applications utilizing 5V, 12V to 48V system. The VDS ratings of the devices range from 12V to 100V and provide solutions for the point of load and power management in both e-bikes and vehicles. Electric motive power has been around since the 19th century, and battery-powered cars were one of the earliest automobiles before ICE became the more popular powertrain. With the introduction of power MOSFET, advancement of semiconductors, and battery technologies, we can now increase the range of electric vehicles by implementing high-voltage battery and associated charging systems. The onboard charger, OBC, takes the AC input from a home outlet or a public charging station, rectifies it to DC power, and charges the 200V to 450V battery. The OBC modules can range from 3.3 kW single-phase to 22 kW three-phase high-power converters, and the system must operate at high efficiency and reliability to achieve rapid charging time. The design of the OBC also needs to meet specific size and weight limits, so increasing power density is critical. To support the AC to DC and DC to DC converters in charging stations and OBC modules, Vishay has introduced a new 650V SJ45 Series Super Junction portfolio. The products have high temperature rating of 175 degrees C to increase thermal headroom and to help extend lifetime of the onboard chargers. A product highlight for the new Automotive SJ2 series is SQW61N65EF, a 650V 52mm device in TO24780 package. This product features a fast body diode, and the reduced QRR improves reverse recovery time to avoid hard communication and to lower switching loss. This part is fully US tested and qualified to AEC-Q101. to support applications such as battery charging, OBC, and DC-to-DC converters. We have a total of 3 part numbers for launching the 650V portfolio, and the RDS(on) has a range from 52mm to 109mm. All the products are in TO24780 package. The DC-to-DC section of the OBC often uses LLC resonant converters, and increasing efficiency requires MOSFET with low RDS-QG figure of merit, a low time-related effective output capacitance plus a fast and robust body diode. The low RDS-QG FOM reduces power loss from conduction and switching of the MOSFET. The low COSS reduces the charging and discharging time to allow switching at 0 voltage consistently. A robust and fast body diode will improve switching behavior during reverse recovery. In order to address these elements critical to efficiency, we have started developing the SJ45 series with fast body diode by reducing the RDS-QG figure of merit, output capacitance, and QRR simultaneously. The SJ4.5 can improve RDS(on) by 47%, and the reduction of on resistance allows us to generate high-performance product in smaller surface mount packages. In a Powerpack 8x8L with SJ4.5 device, we'll have a typical RDS(on) of 50mm and match the SJ2 device in a 90% larger package. This proliferation results in products that can help OBC save weight without sacrificing efficiency and output. The RDS-QG figure of merit of SJ4.5 will also be 68% lower than SJ2, and we expect devices of SJ4.5 deliver higher efficiency than the current generation in fast-switching designs. The release of SJ45 platform is scheduled in mid-2022. And the first device features the typical RDS(on) of 23 milliohm in TO247AD package. We plan on proliferating the technology to Powerpack 8x8L and Powerpack S08L, as both packages enable higher power density and weight saving. This presentation has covered solutions for a broad range of automotive applications. As we approach the end, the key takeaways are: the new wire-free package construction brings out the best of silicon and has lighter weight than devices in transistor outline packages. The resulting products increase efficiency, enable higher power density, and save weight, so the automotive electronic systems can be more energy efficient. The new Powerpack S08L and Powerpack 8x8L have gone through extensive stress testing during the development stage, including mechanical, power, and thermal cycling. The result is increased board level reliability, which leads to extended product lifetime and reduced chance of failure. AEC-Q 101 qualified integrated solutions, such as Powerpack S08L dual asymmetrical package, are available for 5V, 12V, and 48V systems and help reduce component counts, increasing performance of point of load and DC-to-DC topologies in vehicles. Thank you for your participation. It has been a pleasure for me to present our innovation and products for vehicle electrification. The Vishay Automotive MOSFET webpage contains additional information such as case outlines and recommended lens patterns to help you design with our products. Please stay safe and have a wonderful day.
Thank you very much, Brian. That was a wonderful session. We would now like to have Mr. Stephen, Director Product Application from Vishay, as well as Mr. Shiva, Technical Sales Manager from Vishay, to help us answer questions from our audience. Thank you.
Okay, this is Stephen from Vishay. So I saw one of a question in the Q&A tab. So it's the question. Let me repeat the question first. The question is regarding to the Powerpack S08L and the Powerpack 8x8L. Is there any successful case of D2 pack and the D pack replacement for sharing? Yes. So based on the Brian presentation, so we emphasize the Powerpack S08L and the Powerpack 8x8 can compete and replace the D pack and D2 pack, because we got many of these successful case in the market. Our Powerpack S08L and the Powerpack 8x8L package are with a structure of a clip and wire free internally. They performed the advantage of a low plastic inductance, higher power density, smaller size, and lighter weight to achieve higher performance and higher current capability. For example, our SQJQ142, this is Powerpack 8x8, and the SQJA36, this is Powerpack S08L. These two part numbers are popular in the EPS market already. And one in the other part number is SQJ138. This is Powerpack S08L. It's popular in the market of electrical water pump and BLDC fan. So those applications I'm talking about are our D-pack and D2 pack design before, but now changing to our Powerpack package. So we do see the design trend getting happen more and more. This is the first question I saw in the tab. And let me pick up another question. The question 2 is the Powerpack 8x8L is a unique package in the market. So the question is, he's worried about is the sole source in the market or not? The answer is don't worry about that. Vishay has announced this package since 2015, and it has been proved the excellent package solution to perform the performance, size, and the cost. There are many suppliers provide a similar package compatible with our 8x8 package. That means you can find a pin-to-pin second source in the market after you design the visual solutions. And let me emphasize the benefit of this package. This we call it a going lead. There are some of the benefits to perform. The first one is a good suitability. It can perform a very good power temperature cycling, like up to the 2,600 cycles. The second benefit, it can improve the system reliability testing during the ball vibration test, drop testing. The third benefit is it's easily to support AOI inspection if your manufacturer has this machine. Okay, that's all the question.
Thank you very much, Stephen. And thank you very much to all our attendees. We've had a great session today. We hope you all enjoyed it. Thank you very much for the Vishay team for helping us with this amazing content. For any attendees who have any follow-up questions, you can share it in an email with us, and we will share it with the Vishay team. Thank you, and then have a nice evening. Bye-bye.
Thank you.